This is number 1 in the book, and here we're asked to find an exponential function of the form y equals c times e to the power kt, and then they give us some information. So just to be clear, in this section our independent variable is usually t, because the variable is usually time, and the dependent variable is y. So c and k are constants that we're looking for, and again, you kind of have to understand some background that so many functions that are useful in these different areas of science and nature have this form. Y equals a number times e to the power of some number times t. So often when we have a problem involving these exponential functions, we'll know that the function looks something like this, but we need to figure out what c and k are. C and k are just constants that that we can find if we know something about the particular exponential function we're looking for. Okay, and I think this is said in the notes, but the number c is called the initial population or the initial amount of the exponential function, and k is called the exponential growth rate. Okay, but actually, you don't really need to know that to answer this problem. What they give us in this problem is 2 points on the graph, and they ask us to use those points to find c and k. And it's really kind of a basic math problem that's going to involve solving some equations probably. For instance, they tell us 0, 2 is on the graph. Okay, what does that mean? It means that when t is 0, y will be 2. Okay, so if we substitute those numbers into this equation, we'll know that y will be 2 when we have t as 0. So all I've done is I've replaced y with 2 and t with 0. Okay, so 2 has to be equal to c times e to the power k times 0. Okay, well, look at what this tells us. 2 is equal to c times e to the power 0. Okay, k times 0 is 0. But e to the power 0 is 1, so 2 has to be equal to c. Okay, look at that. We already know what c is based on just that one little piece of information. Just that one point, we know that c has to be 2. Okay, well, what else do we know? Well, we know another point. We know 4, 3 is on the graph. Okay, so now we can actually update our model a little bit based on what we found in that first little, using that first little point. We know that our exponential function has to be 2 times e to the power kt, but we still don't know k. And probably there's only one k that will give us this particular exponential function that's graphed. To find k, we have to use the other point. Okay, so the other point tells us that, let's look at it here, when t is 4, y will be 3. Okay, so we know that 3 has to be equal to 2 times e to the power k times 4. Okay, so when t is 4, y will be 3. Okay, well, let's look at this here. There's only one variable in this equation, one thing that we can look for, and that's k. So I can solve this equation for k, actually. If I divide both sides by 2, I'll get 3 halves equals e to the power, well, we could just say 4k. Okay, and actually now, if we want to solve for k, this is where we can use some of our techniques of logarithms. If I take the natural log of both sides, okay, natural log of 3 halves is just a number. You can find that on the calculator at any time. Natural log of e to the power 4k is 4k, right? The natural log and e to a power cancel. So I can divide both sides by 4 now, and I get k is equal to natural log of 3 halves divided by 4. Okay, so that's k, and in fact, probably the only thing we should do, and I'm realizing I haven't done this yet, is give a decimal answer for k. Now, technically this is the exact answer, but in the back of the book on these, you'll probably find a decimal version. So let's go to the calculator and compute this. If I take the natural log of 3 halves and divide it by 4, okay, well, that's about looks like that's about, say, 0.101. Okay, so the conclusion is that our function here is y equals 2 times e to the power 0.101 t. Okay, And this is a pretty typical thing that happens in applied problems. We know there's an exponential function, but we don't know what c and k are. Well, if you can give me just two pieces of information, two little data points on the graph, I can use this idea to find out what c and k have to be for that specific function. Okay. So in a different problem with two other points given, the exponential function is going to be a little bit different.